Morning, everybody. I hope everyone had a good weekend. Back at it this morning. Woke up this morning to snow on the ground. That's kind of disappointing. Anyways, hope you had some fun this weekend somehow. Let's see what we do. Stayed in the house. Going kind of stir crazy already in this quarantine kind of thing, but we're doing the best we can. Let's see, what did we do? Watched a couple movies. Made a big turkey dinner yesterday. Did a puzzle. Read my book. Played a game. I don't know, not very exciting. Okay, so hopefully you guys are hanging in there. Today, actually, we have a pretty short lecture. It's not very long. We're going to talk about making solutions and doing dilutions. That won't take very long, but you do have a short lab to do today also. So we're going to do the chromatography lab. So you'll have 2 videos today, and then you'll have a lab write-up to work on. But the lab write-up for this is going to be short. It's not hard, so don't panic, all right? Okay, so what we're going to do is we're going to start from the challenge question from last week. Last class, and it was 25 grams of KNO3 dissolved in 100 grams of water at 30 degrees Celsius. How many additional grams of KNO3 are needed to make a saturated solution? Okay, and this is a table G problem. All right, so here's my table G. All right, let's just quick review. Remember, it's always in 100 grams of water on here. Right, and here's my temperature. And remember, if we're on the line, that means it's a saturated solution. If we're above the line, that's a supersaturated solution. And if we're below the line, it's an unsaturated solution. All right, so if we look at our problem, first of all, we're working with KNO3. So you got to find the KNO3 line. It's this one. Okay, so we're on this line. And it tells us that we're at 30 degrees Celsius and that we have 25 grams, which is right about here. So here's my line. I'm below the line, so that means this is an unsaturated solution. To get it to saturation, I got to come all the way up to here. And it could dissolve at 30 degrees about, I would say 48 grams. All right, so at 30 degrees C in 100 grams of water, it can dissolve about 48 grams. We only have 25 grams in there. So how much do we have to add? Well, let's subtract off our 25. We would have to add 23 grams of KNO3 to make it saturated. Okay. So that's the answer. All right, now remember, on this, there are really just 3 types of problems. Okay, there's the one that we just did, where you're subtracting. There's another one where we're just looking it up, okay, just using the table like it would. Okay, the question could be, look at, you have 25 grams at 30 degrees Celsius of KNO3. What type of solution is that? And you would say it's unsaturated. Or you might have one of those ratio problems. And the ratio problems are when you don't have 100 grams of water, right? So maybe you have 200 grams of water or 150 grams of water. So as soon as we start changing the amount of water, you're going to do one of those ratio problems, okay? Hopefully you did the homework. And I'll be giving you some answers probably next time. All right, so for today, okay, we're going to talk about how to make a specific solution. Now, I do this all the time. So when I make your solutions for lab, I have to make them in a very specific way. All right, so there's got to be a very specific concentration, and I figure out how much of it I'm going to need for the lab. So I make a lot of solutions. Okay. So what I'm going to do is I'm going to kind of just take you through what I have to do. All right, so let's say that for a lab that I need 500 milliliters of an 8.0 molar NaCl solution. Okay, let's say that that's what I need for a lab. All right, so I have to make this solution. Well, before I even make anything, I actually have to do math. Okay, I got to figure out, all right, how much salt I need to put in my water. All right, so what I'm going to do is I start with the molarity equation. Molarity equals moles over liters. All right, well, I have the molarity, and I can convert this to liters. So I have 8.0 molar solution is what I want. To turn this to liters, I move it 3 places, so I have 0.500 liters. And I want to know how many moles that is. Well, cross multiply, it turns out that I need 4.0 moles of NaCl. Now, there's no machine that measures out moles. Okay, there's no machine that measures out moles, so I have to convert that to grams. All right, well, we know how to do that. Number of moles equals given mass over gram formula mass. Well, I need the GFM of NaCl. Okay, so we got NAs, and we got CLs, and we got one of these and one of these. This is 23. This is 35, 35, 23. Add that all up, and it should be 58 grams per mole. Okay, I need 4.0 moles, so I want to know how many grams that is. Well, it turns out that I need 232 grams of NaCl solid. That's how much I need. Okay, so now, if I was actually going to go to if I was going to make this solution, I would go over to one of the electronic balances. I would take my NaCl and I would measure out 232 grams. Right. Then what you need to do, okay, is we take a graduated flask, like an Erlenmeyer flask. It's got to be graduated. By that I mean it's going to have your volume marks. Okay, so let's say that this is 500 milliliters right here. Okay, maybe 250 here. The first thing you do is dump in the salt. Okay, we put the salt in first, right? So it's down here on the bottom. Then the second thing we do is we add enough water to make 500 milliliters. Okay, so we slowly add water, and you got to be mixing it, all right? You got to be mixing it as you're doing it until we get to 500. Now, here's a question for you. Why don't I add 500 milliliters of water first and then dump in the salt? Well, remember, this salt does dissolve, but it still takes up space. So if I put exactly 500 milliliters of water in first, and then I add my salt, this water level is going to be above 500 milliliters, and it won't be an 8 molar solution anymore. All right, so we add the solid first, and then we slowly add the water. And as we're adding it, we mix and mix and mix and mix, so it's all dissolving until you get to the 500 milliliter mark. And this would be 500 milliliters of an 8 molar NaCl solution. And this is how we do it. All right, let's practice with another one. I actually want you to do one. So here's the problem. We're going to describe in detail how you would make 200 milliliters of a 7.5 molar lithium carbonate solution. All right, so I want you to turn this off for a second. I want you to do the problem. All right, once you're done, turn it back on, and I'm going to go through it with you. Okay. All right. Okay, so hopefully you've done it. All right. So how would you do this? Well, again, you have to start with the math. Okay, molarity equals moles over liters. We got 7.5 molar equals X over 0.200 liters. Okay, remember that's got to be in liters. So it turns out that I need 1.5 moles of the lithium carbonate. All right. Moles equals given mass over gram formula mass. So I need the gram formula mass of this, but before I can do the gram formula mass, I need the formula. Well, Li is +1, carbonate is CO3, which is -2. This comes over here, this comes over here. So we get Li2CO3. All right, so now we have to do GFM. So we got Li's and C's and O's, and we got 2 of these and 1 of these and 3 of these. Lithium is 7, carbon is 12, oxygen 16. Multiply across, we got 14 and 12 and 48. We add and we get 74 grams per mole. Okay. That's going to go here. So that's going to go here. So we have 1.5 moles equals X over 74 grams per mole. It turns out we need 111 grams of the Li2CO3. All right, so now, okay, this was a regions question, all right? So you had to be specific on how to make it. So now what you would say is go to a balance. And measure out 111 grams of Li2CO3. Put it in a graduated flask. You could say beaker, I guess. And then add enough water while stirring. Stirring, swirling. Maybe swirling is better. I guess stirring is better. You know what I mean. Stirring, swirling. Add enough water while stirring to make 200 milliliters of solution. Good. Okay. Yeah, that's not too hard. So this is making a solution. Well, what if we already have a solution? What if we already have a solution and it's too concentrated? In other words, we got to dilute it down. Okay, so this is called dilutions. So what we do, we're going to basically water down a concentrated solution. And we're going to use a different formula. We're going to use M1V1 equals M2V2. This is molarity of the first. This is volume of the first. This is molarity of the second. And this is volume of the second. Okay. Well, let's try a problem. Let's say we have a 425 milliliter solution of 3.66 molar HCl. And we dilute it we add water to 1.0 liters. What is the new molarity? All right, so this is V1. This is M1. This is V2. Okay, so now we just substitute. M1 V1 equals M2 V2. 3.66 molar times 0.425 liters equals X times 1.0 liters. We cross multiply, and it turns out that when we add enough water to get to 1 liter, it is now a 1.6 molar HCl solution. All right, let's try something just a little bit different. Let's try this. How would you make a 1.33 molar H2SO4 solution using 35.0 milliliters of a 10.0 molar H2SO4 stock solution. All right, so this is another thing that I do all the time. All right, our acids, which is what H2SO4 is, comes in a really concentrated form, and if I ever gave you 10 molar H2SO4 during a lab, you could really burn yourself, so I have to dilute this down. All right, so this is a dilution problem. All right, so I'm going to use M1 V1 equals M2 V2. All right, my original molarity is 10, and my initial volume, I'm going to move this 1, 2, 3, is 0.035 liters. Okay, the new molarity I want is 1.33 molar, and I want to know what the new volume of that is. Okay, so when we do this, X turns out to be 0.26 liters, which is 260 milliliters. So what I would do is I would take this stock solution, or I'd take this solution, right, 35 milliliters, and I would add enough water to get 260 milliliters. Okay, so I just add water until I get to 260 milliliters, and that would dilute it down to 1.33 molar. Okay, pretty easy stuff, not too bad. All right, now that's all the lecture for today. We're going to do a lab. All right, it's short. All right, so you'll have this video, and then I'm going to make a second video, so I'll post both of those at the same time. All right, a little bit of homework tonight. I hope everything's going well. I hope everyone's healthy. I miss you guys, actually, and we'll talk to you again tomorrow. Have a good afternoon.